Consider the function f of x is equal to x cubed plus 48 over x, and x is not equal to 0. We can't have x equal to 0 because we're dividing here by x, so that is not possible. So calculate f of 2. So we're going to put this in. Now it's very important that you actually show this working, because this is required to get the 1 mark. So you put that in, and then you're going to solve. You can use your calculator obviously if you want to. 2 to the 3 is 8. 48 divided by 2 is 24. 8 plus 24 is 32. So that's 2 marks. So 1 mark is for putting it into the equation, and 1 mark is for getting the answer. Then it says sketch the graph of the function y is equal to f of x for this domain and this range. Now I have got it here in my calculator, so I have put in my graph there in the equation x cubed plus 48 over x, and notice also for the window I have put in these values into the window so that I have them. So it's from -5 to 5 and from -200 to 200. I've made my y scale to be 10 because this is a large amount, where this I made the y scale to be 1. Notice also in the table set, because the table is useful, going to my table, it automatically starts from where you're at. So it's we're starting here. We want to start this at -5, so I put -5 in there, and I've got here my increase each time is going to be 0.5. That just may help me to get some extra points if I need. That's very useful for drawing the graph, because you then go to your second and you go to table, and these give you all the points that you can plot. Now you don't need all of these points, but you need a good number to be able to draw a good version of your graph, which should look something like that. Now I have actually put up here, and I'm just going to show this to you, the mark scheme for the graph. You should be getting something like that, where you have done it from -5, from -5 to 5. So you've got that on your x and your y axis up to 200. So you've got a value of your scale, you've got your x and your y. Many of you forget to put your x and your y and also a value of the scale. And then you've plotted certain points. So you would plot a nice range of points there. You've got a good idea. Now in this graph over here, you can see that we've got an asymptote here. This is it. And you've got to show it drawn all the way down past your 200 to get your mark. Now to get your full marks for this, you would have to have done the following. The first mark is for labels and some indication of scale in an appropriate window. So you need a scale and also for labels. Now notice here the axis, you should be it said need not, but I would always draw with a ruler. When drawing the graphs, it says over here, must be smooth, a single continuous line that does not deviate from its proper direction. So you can't do something like this or something like that. You can't do a shaded line. It's got to be a single line. So you've got to practice this. This comes with practice, and over the next couple of months you really need to practice your drawing of your graphs, that you do a nice curved line. You've got your calculator, which gives you a good idea of how the graph should look, and it should continue going down all the way there. This would be, I would need to redo that one. The position of the maximum and minimum points must be symmetrical about the origin. So this point over here, these 2 points over here, had to be in the right position. That's the point that we were actually checking, that those two were symmetrical about the origin. That is equal to that. And then the y-axis asymptote must be the y-axis must be an asymptote for both branches. Neither branch should touch the axis, nor should the curve approach the asymptote and then deviate away. So you can't do this, which is quite possible to do. So you go down like this and then you go away like that. It's got to always keep on getting closer and closer. So in the drawing of these graphs, if you want all 4 points, you've got to make a very good attempt at it. It's very easy to lose marks on drawing these graphs. Good, so we've got our graph drawn. Then it says find f prime of x, so we're going to differentiate this. Now remember, when doing this, we firstly write it in this form, plus 48x to the minus 1. Bring that up to the top, bring that and call that negative 1. And now when we differentiate, we use our rule, obviously. It's going to be 3 times the 1, so it's going to be 3x, and then you're going to subtract 1 from the 3, so it's going to be squared. Here you're going to have minus 1 times the 48. Many of you forgot to do that, so you put plus 48, but it's actually minus 48. And then it's going to be x, and it's minus 1 minus a further 1, so it's going to be minus 2. So it would look like that. You could write it like that, or you could write it as 48 over x squared, either of those two. And there's 3 marks for this. There's a mark for that, there's a mark for that, for the minus 48, and there's a mark for the x to the minus 2. Then it says find f of 2. Now it's very important in doing these that you show some working. So you've got f prime of 2. You need to do the step, you need to write this in. You can't just do it into your calculator. So you're going to get 3, use your brackets, 2 squared minus 48 over 2 squared. So even if you make a mistake in this, if you show your working here, you'll get full marks from here on. So obviously this is going to be 2 squared. The square is only for the 2, so it's going to be 4 times 3 is 12. And then it's 2 squared is 448 divided by 4 is also 12. So your answer would be 0 for that. Then it says write down the coordinates of the local maximum. Now here we go back to our graph. Now in this graph you can see that you've got this is going up and then down. So this is going down and then up. So here, this point over here would be a local minimum. This point over here would be a local maximum. So we would use our calculator to find this, because it says over here write down the coordinates. So you're not actually needing to find this with algebra, you can just get it straight from your calculator. So you do second function calc, you're going to find 4, you want to find a maximum. Now you've got to get it to where you need it, so you've got to move this along until you see this point flashing. Sometimes you can't see it, so you've got to go to the left of that local maximum, obviously, push enter, and then you've got to go to the right of it and you push enter, and then you guess it, and it is 2 and y is equal to minus 32. So it's minus 2 and for x, and y is equal to minus 2. So the coordinates, you always write it in this form, minus 2 and minus 32 would be your value. Now this point over here, in the next we're going to find the range of f. Now the range is from where to where on the y-axis. Now if I'm looking at this graph, can we see that the graph goes on the y-axis, it goes, the maximum point, it goes up to there, and then it goes there. So this is negative 32. If you find the local minimum here, this is actually 32, it's 32. So you're going to have the union, you're going to have y is greater or equal to 32, and the union of y is less than or equal to negative 32. It's the combination of those two. you're going to have for your range. The range is from where to where on the y-axis. Then it says find the gradient of the tangent to the graph of f at x is equal to 1. So here we're going to we're trying to find the gradient of the tangent. So we're going to go to our gradient function, which is this one over here, but now we're going to put 1 into it. So we're going to find f prime of 1, and that is 3. You got 1 squared minus 48, and it's all over 1 squared. So we've got that, and obviously this is going to be 3 minus 48. That's going to equal negative 45. And then find this over here. There is a second point in the graph of f at which the tangent is parallel to the tangent at x equal to 1. Find the coordinate, x coordinate of this point. So we've got that at x is equal to 1, over there we've got a tangent, and that tangent over there is equal to the gradient is equal to negative 45. Now notice that this over here is 2 marks, so we've got to show us a bit of working here. We want to find the x coordinate of that. Now obviously when I look at the symmetry of that and that, you would also get a tangent like that. Alright, now if we put this into our equation over here, we can actually find it, but just by drawing it on the graph we can see that that would actually happen when x is equal to negative 1.